Hello, I am going to go through everything from section 7.5, so we're going to talk about interior angle measures of polygons and exterior angles of polygons. So I'll start off with a couple problems just dealing with the sum of interior angle measures. So for this, we're going to use the formula where the sum of the interior angles is equal to the number of sides minus 2 times 180. So this concept kind of came along with when we were talking about triangles having 3 sides, and if you took 3 minus 2 and multiplied it by 180, that's when we had 180 degrees being the sum of all the interior angles of a triangle. So we can apply it to any sided figure. So in this case, we're going to use the sum of a 30gon, so a 30-sided figure. I'm going to do 30 minus 2 times 180, so then that's going to simplify to 28 times 180. And in the calculator, I end up with a total of 5,040 degrees. So if you drew a 30-sided closed figure and brought a protractor out and added up all the measures of the angles, you would get 5,040. Working backwards, we're going to calculate the number of sides a polygon has if the interior angle sum was 3,060. So I'm going to take the same formula that I have in black, except in for the letter S this time. I'm going to solve for 3,060. And we are going to be solving for n. So the first thing that we can do here, we'll realize that this entire quantity is being divided, or is being multiplied by 180. So if we divide both sides by 180 first, it's going to get rid of the 180, and I would end up with 17 equals, and then this goes away. So I'm left with n minus 2. So if you wanted to solve for n, rewrite it right here, all that we would have to do then, all that we would have to do is add 2 on both sides. So if I add 2, I end up with 19 equals n. So this is a 19-sided figure, would have an interior angle measure sum to 3,060 degrees. For this one, we're going to talk about a regular polygon, and a regular polygon means all 26 sides have the same measure, or length, and all 26 angles have the same measure. So there's a formula for this, and we're going to start with the same, I'm going to use x equals instead. We're going to say x equals, we're going to take the number of sides minus 2 times 180, because that would give you the sum. Now if you divided it by the number of sides, it would tell you the measure then at each one of the corresponding angles. So it's a 26gon, so I'm going to be substituting 26 in for n in both places. So on top, I'm going to end up with 24 times 180 all over 26. So the numerator is going to come out to 4320. Your denominator is 26. And again, what we are solving for is the measure at each one of those interior angles. I'm going to round to the nearest hundredth, so it's going to be 166.15 degrees. Now we're going to work backwards on a problem like that. So what if I give you if I give you each one of the interior angle measures, and we want to figure out how many sides that figure has? So I'm going to write out that formula first, and we'll take a sec to talk about it. We are going to be solving for the letter n in this case, and it appears twice in here. So I'm going to take the 162, which represents the measure of each one of those interior angles, and that's what we're substituting in for x. So what I'm going to do then in order to solve this is multiply both sides by n, and that's going to get rid of this n in the denominator. So my left side, I have 162n equals n minus 2 times 180. So what I'm going to do next is use the distributive property here, and I'm going to write it out on the top right over here. I have 162n equals, and if I distribute this properly, I'll get 180n minus 180 times 2, which is 360. So then in order to solve this, the 180 is positive on this left side. I'm going to bring it over to the other side by subtracting it. So I'm going to subtract 180n on both sides. So in your calculator, you're going to do 162 minus 180, end up with negative 18n on the left side. This cancels, and that's going to be equal to negative 360. So what we are solving for is the number of sides in this figure. My last step, if I divide both sides by negative 18, I end up with n, which represents the number of sides in this figure, and it is going to be 20. So this is a regular 20gon. And now we'll move on. We're going to do more of an application of this. This one's going to kind of be a little bit of a process. What we're going to do is figure out the value of x here, and then we're going to use that value of x to figure out the measure of angle E by substituting in our value for x. So first thing we're going to have to do is count how many sides this figure is. It looks like a 5-sided figure, which is a pentagon. And we need to figure out, oops, that says gom. We need to figure out what the sum of the interior angles is, since all of these quantities represent interior angles. So I'm going to use the formula that says S equals n minus 2 times 180. And we are given that is a 5-sided figure. So I'm going to do 5 minus 2 times 180. Simplify, that gives me 3 times 180. So you end up with an interior angle sum, meaning if I add all those angles together, I'm going to end up with a total of 540 degrees between all of these 5 angles added up. So that would be our next thing then, is to take each one of these quantities. I'm going to start with the letter A, and I'm going to work my way around the figure, and we're going to add up every one of these. So I'm going to write it all out. This is going to be insanely long. 5x plus 2 plus 3x plus 5 plus 8x plus 8 plus 4x plus 15 plus 5x plus 10, and that is going to equal 540 degrees because that is the sum of our interior angle measures. So it looks like a really big, long, complex formula, but we're just going to combine our like terms. So I'm going to start with x's. We're going to take 5x plus 3x, which is 8x. If I add another 8x, that's 16x. Add 4, that's 20x, and then I'll add the 5. So I'm going to have a total of 25x, and then I'm going to add the whole numbers. 2 plus this 5 is 7. I add the 8 to get 15, add another 15 gets me 30, and add the 10 and I get 40. So I'm going to set that equal to 540, and now we just took this really long giant green equation and I made it look a little bit nicer. So what I'm going to do is subtract 40 on both sides, and I'll be left with 25x equals 500. So then x was part of our question, comes out to 20. So we did find the value of x. Now I have to use that value of x, and we're going to determine the measure of angle E. So I'm going to switch color one more time, and angle E is this corner right here. So the measure of angle E equals 5x, so 5 times 20 plus 10. So 5 times 20 is 100, and 100 plus 10 is 110. So the measure of angle E is 110 degrees. So we have successfully done the two things that the problem was asking for. So that was an application of using the sum of the interior angles. Now we're going to talk about a little bit about exterior angles, which is going to bring in that keyword supplementary, where the interior angle and the exterior angle are going to add up to a total of 180. And the reason for that, if I draw any kind of figure, this is a really ugly figure, but if I pretend this on the inside, I'm going to call this angle A. If I extended a straight line coming from every one of the sides of this polygon, and I looked at just these two angles right here, and I called this B. Well, A is the interior angle. B is what we would call the adjacent exterior angle. Adjacent means it's next to it. So if you added the two of those together, since they're a linear pair, they are supplementary, they have to add up to 180. So that's going to be what we're going to do in this problem. We're saying if the interior angle is 124 degrees, I want to figure out what the measure of the exterior angle is. So what I'm going to do is subtract 124 on both sides and end up with an x value then of 56 degrees. So then what I'm going to do in the next problem, we're going to talk about more of the exterior angle measures. And this time, I'm going to give you a concept, because I think these are the last problems then. Yes. Okay. So the last concept then is that if I take, and I'm just going to put a random polygon down here. If I take, do I have a pentagon? No, I have a hexagon. Let's use a hexagon. If I take a hexagon and I make the exterior angles with all these marks, blah, 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 blah. Any shape that you do this on. So I could have picked a pentagon, a hexagon, a decagon, a nonagon, a 15gon for all I care. If you add up all of these exterior angles on the outside, I don't care how many sides are on the figure, it's always going to add up to 360. Think about it like a full circle. Circles add up to 360 degrees. That's what's going to happen for these exterior angles. They're always going to sum up to 360 degrees. So what we're going to do then is calculate the number of sides of a polygon whose exterior angles measure 12 degrees each. So if I know that they sum up to 360, I'm going to divide it by the measure at each one of those, and that is going to give me the number of sides then. So if you have a 12-degree angle, you would take 12 degrees at each angle times the 30 sides, and that would give you 360. So our final answer is really just this 30 sides. You're just dividing. We know, again, that the sum is 360, and if each angle measures 12 degrees, that means there's 30 sides. So we're going to kind of take that logic and apply it to this last one. It says, what is the measure of each exterior angle of a regular decagon? So a decagon is a 10-sided figure. So if I have a 10-sided figure, and I know that all of those outside angles are going to add up to 360, I'm going to take 360, I'm going to divide it by 10 for the number of sides, and that's going to give me 36. What that means is that each of those exterior angles of a regular decagon, so if I took a 10-sided figure that had all the same side lengths and all the same angle measures, each one of those exterior angles would have to measure 36 degrees. And again, that's those last little couple problems, we're just dealing with exterior angles, so that's just the new stuff. And that is all the material that you would need to know about interior and exterior angles.